In this example, we're going to see how we can apply the commutative property of addition to make a problem more simple. So Raj recorded his weekly expenditures and deposits in a notebook. He wrote down the following expression to represent the current balance. So maybe you can imagine this. He started with $1,230, subtract 50, so he paid something or took out cash, subtract 20, subtract 8, add 120, subtract 72, subtract 160, and then deposit 340. So let's find the balance in Raj's account by doing this from left to right. So since there's addition and subtraction, we need to do this from left to right. So I have a calculator here, and we're just going to punch in these operations and do them one at a time. So 1230 minus 50 equals 1180. Then, so we've done this. Let's get a highlighter ready. Now we want to subtract 20, minus 20, enter, minus 8, enter, plus 120, enter, minus 72, enter, minus 160, enter, and then plus 340, enter. So we get the balance is $1,380. So that was a little tedious. It wasn't that bad with the calculator, but let's see how we could use a commutative property to maybe speed this up a little bit. So we learned that subtracting a number is the same as adding its opposite. So we're going to rewrite this expression using addition. So 1230 plus negative 50 plus negative 20 plus negative 8 plus 120 plus negative 72 plus negative 160 and plus 340. So notice now all of the operations are addition. Okay, so we have positive numbers and negative numbers, but it's all addition. So by the commutative property of addition, we can add these in any order that we like. You could think we could interchange these two or these two, and any combination thereof, rearranging these in any way we want. So what we're going to do here is we're going to make a list of the deposits, which are the positive numbers, and the withdrawals. So we have a positive 1230, scanning along, 120, and 340. For the withdrawals, these are negative numbers, but I'm just going to write them as positive numbers in a negative column. So we have 50, 20, 8, 72, and 160. Now let's find the sums. So I'm going to add these by column. So we have 0 ones, we have 4, 5, 6, 7, 8, 9 in the tens place, 6 in the hundreds place, and 1 in the thousands place. So we had a total of the positive entries or deposits, including the initial amount, which we're thinking of as a deposit, is $1,690. Now let's look at the withdrawals. So adding in the ones place, we have 10, so that's a 0, carry a 1. Now we have 1, 6, 7, 8. 8 and 7 is 15. 15 and 6 is 21. So 1, carry the 2. I'm going to put that up here. And $310 in withdrawals. So now that we've combined these together, we know that this is $1,690 plus negative $310. So we have two numbers we're adding. They have different signs, so we subtract and keep the sign of the larger number. The larger number is $1,690, so his balance is going to be positive. and I'm going to subtract 310. 0 minus 0 is 0, 9 minus 1 is 8, 6 minus 3 is 3, and 1 minus 0 is 1. So his ending balance is $1,380, which aligns with what we got originally. So basically the idea here is even though this is subtraction, and we have a lot of subtraction in here, we can still use the commutative property of addition by thinking of the subtraction as adding the opposite of the number. Then you can combine all the positive numbers and all the negative numbers, which is easy because you're just adding straight across positives and negatives, and then in the end you'll just have to do one subtraction.